Hello, I'm Mr. Howard. In this video we are going to use long division to help us factor and find roots of these more complicated polynomials. And we've done long division in our previous lesson, and we can also use synthetic division as well, but in this video I'm just going to use long division. Okay. So example 1 says divide x plus 2 into f of x equals 2x cubed plus 3x squared minus 8x minus 12 to demonstrate that it is a factor and that x equals negative 2 is a root. Okay, so if x plus 2 will go into 2x cubed plus 3x squared minus 8x minus 12 evenly, then we know that it is a factor, so x plus 2 would be a factor, and that would result in x equals negative 2 being a root. Remember, our roots are opposite of these signs here. Okay, so if x plus 2 is a factor of this thing, that stands to reason that x equals negative 2 must be a root. Alright, so we are going to just use long division here. So we have x plus 2 and 2x cubed plus 3x squared minus 8x minus 12. Alright, so what times x would give us 2x cubed? Well, that would be 2x squared. So 2x squared times x is 2x cubed. That's what we wanted. With long division, we always subtract. Remember, with synthetic division, we always add. Alright, 2x squared times 2 would give us a plus 4x squared. Okay, these cancel, that's what we want. So we have 3x squared minus 4x squared gives us negative x squared. Then we bring down this negative 8x here. Now, what times x gives us negative x squared? Well, that's a negative x. So negative x times x, negative x squared. That's what we wanted, so these cancel. Negative x times 2 is negative 2x. So we have negative 8x minus negative 2x. That's going to give us a negative 6x. Remember, we're doing the opposite of this sign here, so because of this minus here. So we end up adding 2x to negative 8x to give us the negative 6x. Then we're going to bring down this negative 12 right here. Alright, what times x gives us negative 6x? That would be minus 6. Negative 6 times x, negative 6x. Negative 6 times 2 is negative 12. We're subtracting these, and this all cancels. We have a remainder of 0. Therefore, x plus 2 is a factor of this 2x cubed plus 3x squared minus 8x minus 12 polynomial. So we can now rewrite this as x plus 2 times 2x squared minus x minus 6. Alright, so we have proven here that x equals negative 2 is a root of this polynomial right here. Alright, so let's move on to example 2. Alright, here we have example 2, and in example 1 we found that x plus 2 was a factor of our original f of x function, and we were left with 2x squared minus x minus 6 when we were finished. So far we have this broken down to this point. Example 2 is asking us to completely factor it and find the other two roots. Remember, we had a cubic to begin with, and that's a degree 3, so we expect to have 3 roots. Alright, so 2x squared minus x minus 6 still needs to be factored so that we can identify those roots. Remember, we're setting this equal to 0 to find our roots. And we could use the box method to factor this, or we could use guess and check to get this thing factored. And if we did, we would find that it would factor to, I'm going to write the x plus 2 first. This will actually factor to 2x plus 3 times x minus 2. Alright. And we can factor that, like I said, but I'm going to show you and remind you how to use the quadratic formula, because that will always work, and you're going to need that further down in the assignment. Okay? So remember that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and since we are trying to factor, or we're finding the zeros of this trinomial here, we have an a value of 2, a b value of -1, and a c value of -6. All right, so I'm going to write those out here. A equals 2, b equals -1, and c equals -6. We need all of those to plug in here, so now we're just going to plug this in. So negative of -1 becomes +1. So it's 1 plus or minus the square root of b squared. So -1 times -1 is +1. Minus 4 times a is 2 times c is -6 all over 2 times a. 2 times 2 is 4. Alright, so let's break this down a little more. So we have 1 plus or minus the square root. We would have 1 minus 4 times 2 is 8. 8 times -6 is 48. So we have two negatives here, so that's going to be plus. So 1 plus 48 gives us 49. Okay, you can check me on that, but I'm pretty sure that's right. And then all over 4. So to finish this, we would have 1 plus or minus the square root of 49 is 7 all over 4. Okay, so the positive would be 1 plus 7, or 8 over 4, which equals 2. So that's one root. The negative 1 minus 7 would be -6 over 4, which will reduce to -3/2. So that's our other root, or -1.5. So we have found the other two roots to be 2 and -3/2. Remember, we already had x equals -2 as a root from example 1. So our three roots are -2, 2, and -3/2. Okay? So here are all three of our roots. Alright, I'm going to work some of the problem 3 and problem 5 from your assignment section as well in the remaining part of this video. Alright, here we have number 3 from your assignment section, and in the assignment we were asked to use long division to determine if f of x is divisible by g of x. If factorable, completely factor f of x and find all the roots. Okay, so they give us f of x here. So we have a degree 5 polynomial, so we are looking for at most 5 total roots, and they give us g of x is x squared minus 3. This would not be a candidate for synthetic division. Our leading coefficient is 1, but our x term has a power of 2, so we actually are forced here to use long division. So let's get that going here. So we have x squared minus 3, and we need to divide our other polynomial by that. So x to the 5th minus 3x cubed plus 8x squared minus 24. Alright, so what times x squared gives us x to the 5th? Remember, our rules are when we multiply like bases, we add their exponents. So this is going to be x cubed. X cubed times x squared, we add the exponents, so it's x to the 2 plus 3, which is x to the 5th, and that's what we want. So x to the 5th here, x cubed times -3 would give us a -3x cubed. Okay, we're subtracting here, remember. So these would cancel, that's good, and these actually cancel. So we bring down a 0 here, and we're left with 8x squared. And then we can go ahead and bring down the minus 24 here. So we would have, now what times x squared gives us 8x squared? That would be a plus 8. So that gives us 8x squared. We're subtracting here. 8 times -3 is -24. So 8x squared minus 8x squared cancels, like we said, and these actually cancel. So we're left with a remainder of 0, and we know that x squared minus 3 is a factor of this polynomial, and x cubed plus 8 is another factor of it. So we have proven that x squared minus 3 times x cubed plus 8 is are factors of this, and multiplied together they would give us this part. Alright, so we're not done though. We have to set this whole thing equal to 0, so we're actually going to have to factor this down some more. So we have x squared minus 3 and we have x cubed plus 8. So let's just start with the x squared minus 3 part. So remember, if these two things multiplied together equal 0, one of them must be 0. So either this one is 0 or this one is 0. So we can set each factor equal to 0 and solve for x. So we would add 3 here, and that would give us x squared equals 3. So x equals plus or minus square root of 3. Alright, so there are two roots there. We have x equals the positive square root of 3 and x equals negative square root of 3. Alright, now x cubed plus 8, I'm going to bring in our factoring patterns from our very first unit earlier in the year on algebra review. And remember that the sum of two cubes, that's it right here. That's what we have. We have a sum of two cubes. We have a cubed plus b cubed. So our a value is the cubed root of x cubed, which is x, and our b value in this pattern is the cubed root of 8, which is 2. Okay, so we're just going to fill out this pattern, and that will factor it for us. So x cubed, I'm going to do that one over here. X cubed plus 8, x cubed plus 8 is going to factor to x plus 2, and then x squared minus 2x plus 4. Okay, just using our pattern here. That's all I did here. Applied that pattern. Our a value was x and our b value was 2, so we have x plus 2. Slide this over here so we can see actually what we did. Alright, so we had x plus 2 and then x squared minus 2x plus 4. Okay, because our a value was x again and our b value was 2. Alright, that's all it did. Okay, so we now can say that this thing is still set equal to 0 here. I'm kind of running out of room here. I'll put a bar there to make sure we keep that separate. So we have x plus 2 equals 0, therefore x equals negative 2. So here is another root. I'm going to box these in. So now we found 3 total roots. Now we need to try to factor this piece down some more so we can get the roots from this. This is a quadratic, so it should have 2 more roots. That would give us our 2 here. This makes 3, and then we have 2 here, so that's 4 and 5. So that'll finish this out. But this one will not factor, so I'm going to have to use the quadratic formula. So underline this in green. Our a value here equals 1, our b value here equals negative 2, and our c value here equals 4. So let's plug that into the quadratic formula and work from there. So it's negative b, so it's positive 2 plus or minus the square root of b squared. That would be 4 in this case. Negative 2 times negative 2 is 4. B squared minus 4 times our a value of 1 times our c value of 4. Alright, all over 2a. So that would be 2 times 1 is 2. Okay, so this equals, I'm going to draw a bar here, we're running out of room. That would be 2 plus or minus the square root of, this would be 4 minus 16, which is, let's see, 4, let me make sure I did that right, yeah. So 4 minus 16 is negative 12, all over 2. Alright, so we need to break this thing down so we can come down here in another color. So that's going to be 2 plus or minus, this is going back to algebra 2 here. We can make this negative 3 times 4. We can rewrite negative 12 as negative 3 times 4, all over 2. The 4, the square root of 4, will come out as a 2 out in front. So that's going to equal 2 plus or minus 2 square root of negative 3 all over 2. I'm going to go ahead and factor the 2 out because we have a 2 in this term, and then of course down here. So that is equal to 1 plus or minus the square root of negative 3. Remember, we factored out this 2, this 2, and this 2. So that's all that we are left with. Remember from Algebra 2 that we can't take the square root of a negative number. So we're going to rewrite the square root of negative 3 up here as the square root of 3 times negative 1. And we had a solution for the square root of negative 1 that was equal to I. So finally, this is equal to 1 plus or minus the square root of 3 times I, or just I square root of 3. Okay? So that was a long drawn out process. So we have 2 factors here, we have 2 factors here, that makes 4, and then we had our 5th factor right here. So I'm going to box this in. Alright, and they wanted us to completely factor this, so let's go ahead and do that so we can keep this separate. I'm going to go ahead and use another color here. So altogether, this thing fully factored all the way down could be written as, I hope I have room here, I'm going to draw a line down right here. So that would be, we had the x plus 2, so x plus 2. We had, let's see, where else did we have work that was done? We had the x right here. We have x plus square root of 3. We have x minus square root of 3. That was from this one right here. And then right here, I'm going to run out of room here. This is still all multiplied together. I'm going to have to rewrite this in a minute. X minus 1 plus I square root of 3, and x minus 1 minus I square root of 3. Alright, so this is all multiplied together. So I'm going to scroll this down a little bit and keep writing here so that we get this all together. So it would be f of x equals. I know this is a complicated problem. Okay, there was a lot to it. That's why I went ahead and worked this one in the video. Alright, so all together, writing all of this side by side, it would be x plus 2 times x plus square root of 3 times x minus square root of 3 times x minus 1 plus I square root of 3 times x minus 1 minus I square root of 3. Alright, so let's talk about where each one of these came from. So this x plus 2 came from up here, from this factor right here. So that one we did in pink. The x plus square root of 3 and x minus square root of 3 came from this blue part. Alright, so there and there. Realize if we set this equal to 0, we would get x equals negative square root of 3. If we set this one to 0, we would get x equals positive square root of 3. So again, that's this part. And then the most fun was this one right here in orange. So we have, if we set this, we had 1 plus or minus I square root of 3, so we actually had 2 roots there. And remember, x minus this whole thing is what we have to have as the factor, because if we set this thing equal to 0, we would end up getting x equals 1 minus I square root of 3 here, and we would end up getting x equals 1 plus I square root of 3 here. So that would give us the two roots there. All right, so we have 2 roots here, 2 roots here, and 1 root here for a total of 5. So we know we are done. All right, so one more problem and this video will be done. And again, I can understand if you're worn out after going through this one. That was a long problem. All right, so let's look at, I think I was going to look at number 5. Yes, number 5. All right, here we have number 5. So this one is a little bit different. I think you'll see it's pretty straightforward, but they ask us to determine k so that x minus 4 is a factor of x squared minus 6x plus k. So we need to find what the constant must be in order for x minus 4 to be a factor of this thing. So we can use long division to do that. So it would be x minus 4 needs to divide into x squared minus 6x plus k. All right, so we just go through the long division process. So what times x gives us x squared? That's just x. So we have x squared here. We're subtracting. Negative 4 times x is negative 4x. That's going to negative 6x minus negative 4x would give us a negative 2x. And we need to bring down the plus k. All right, so what times x gives us negative 2x? That would be minus 2. So that's minus 2x. We're subtracting here. Negative 2 times negative 4 is positive 8. So right here, we need to do k minus 8 needs to equal 0 when we're done, so that we have a remainder of 0. So 8 needs to be 8, right? Because we need, in order for this to work, k minus 8 must equal 0, right? So k minus 8 must equal 0. Therefore, k has to equal 8. We just solve for k here. So there's our answer. All right, so it seems a little different, but it's really not too bad. All right, that's it for this video. I will see you in the next one.